the battery electric vehicle, the plug-in hybrid vehicle, and the hybrid vehicle. And what are the choices? And why? How should people take it up? Because we need to have some sort of decisions factor will be there, will decide that we want to buy an electric vehicle. There must be some reasons for buying it, okay? Uh, the most important thing I think is the price of the vehicle. The price of the vehicle is very important, okay? We have to look at the constraints globally that has been imposed. Uh, Fuel prices are very volatile. In Australia, at the moment, because of COVID, our prices are pretty good. It's about between 99 cents and 114 cents a litre. But that could have fluctuated up to 180 cents. So people are not very happy with petrol prices the way it is going, and they're looking at electricity prices. Then this is a very important thing, vehicle range. Say Tesla can do much more longer distance compared to your Nissan Leaf. So that will be very important. We do drive a lot in Australia, and in Australia we find that because we drive long distances, uh, and say from Melbourne to Sydney, it's about 840 kilometers, and I normally drive between 8 to 10 hours, and I reach Sydney. But is that vehicle range such that I get enough charging station where I can charge my cars? Then are there any public charging infrastructure? And that's important because you see that we got hundreds of petrol stations between Melbourne and Sydney. Okay, but are there any infrastructure? At the moment, we have got 16 charging station between Melbourne and Sydney is good enough because people know that they can charge at every frequent instant. Then the most important thing, and many people are interested in that, is to look at the green credential. So we are planning to have large number of electric vehicles. Okay, and most of them will come from overseas. We're planning that most of them will come from overseas, right? And so there are constraints with supply, and there could be limiting growth in our market. Then some of the cars which are there, this is the classical um, battery electric vehicle. So it's a tiny car, um, and it is a reasonably priced, $48,000. Comparatively, I could buy another car, IC engine car, which about between 14 and $15,000. So I find that to be three times more expensive, and you can pay back this in 43 years. Um, People like me who are big in size, we find it very difficult to go into that Mitsubishi car. Then the Nissan Leaf. This is a very popular one. This is a very popular one. The range over here is 160 to 160, 100 to 160 kilometers. It seats five people, and it's available reasonably at $30,000. And we can say that this can actually be a good uh, performer, and it can compete. There is Holden Bolt, right? But look at that. This is plug-in hybrid electric vehicle. The range is not as good as the Nissan Leaf, uh, but the price is three times that of a conventional car. Now that is a very big deterrent to buy that car. The Renault is there. Again, Renault is again a battery electric vehicle. You can swap this battery in 4 minutes. So one of the good things about this is that if there are normal petrol station, also they can keep batteries over there. In 4 minutes, you can swap it. And the good thing is that the range is much better, 185 kilometers. And this acts like a real car. This is not a Mickey Mouse car, and it is closer to what people expect. And my favorite is this one that you see. The problem with this is that $200,000 is the price, and the range is fantastic, 394 kilometers. So if I was to drive from here to Sydney and back, I can do 5 time charging and uh, cover that 1,700 kilometers up and down from Sydney um, with 5 fillings. And normally with a petrol engine, I would spend about 5 to 6 fillings also. So this is very good. But the problem I have is this $200,000 price. Even the second-hand one is half the price, which is very cost prohibitive. I believe that this one, the new model, that S model, this will be a very popular model. The range is pretty good, 500 kilometers, and the price is very reasonable. And you'll be surprised in the United States, this car outsells Porsche and Audi. So see, this must be a good one. Then there's another one that Tesla is looking at, and that's very good. It looks very nice, very trendy. But you understand that the cost is more. So, but I know that Tesla is intending to introduce cars for $30,000 in the next 3 to 4 years. They're looking at merger with Apple. They've got supercharging station in Germany, in Autobahn. Half of Germany has already got a switchgear station, supercharging station, and you charge for 30 minutes every few hours. So Tesla has got facilities to do that. Now, China using electric vehicle has resolved air pollution, and I will show you in my second lecture. India too has solved air pollution in Delhi by using electric rickshaw, and I will show you some pictures of that. So in China, you have got everything is e-mobility, whether it's e-bike, e-cars, e-buses, and they're looking at mass production. Once you look at mass production, the cost will completely go down. Now, if you look at the supply constraint and the price of the vehicle, naturally, it is a premium because the price is for the cheaper one model to a medium size model. It's anything between $20,000 to $50,000 compared with ICE, the internal combustion engine. Um, it is premium to purchase in Australia versus internationally. In Australia, we have got less incentive, like internationally, there are a lot of tax incentive to buy an electric car. But if you look carefully, it is much cheaper to operate. To operate a petrol driven car or internal combustion engine car, it costs you about $11.25 per 100 kilometers. Whereas electric vehicle can cost you anything between $2.30 to $5.70 per 100 kilometers. So it's roughly about half the price. The running cost or the cheaper is the petrol or electricity. Petrol versus electricity, it is cheaper to buy um, the electric vehicle. In the long run, you find that that is cheaper. Then the petrol prices, naturally, when you look at carbon price, they favor the ICE vehicles, right? The electricity prices has been going up, right? Maybe not the consumption has gone up, but the prices are going up. And this is the high price scenario. Then the life cost cycle, it depends on what type of cars you have, whether you have the natural gas one, the battery electric vehicle, the plug-in hybrid electric vehicle, or the hybrid electric vehicle, or the IC engine. And depending on that, you find that the battery electric vehicle, it has a much better performance. And if you look at it carefully, the lifestyle is no different than your IC engine car. This is at a low kilometer. And naturally, at a high kilometer, the battery one performs much better than any other car. Now, someone might say that the range is a problem because most of them, as I mentioned, ranges between 80 to 160 kilometers unless you're going for Tesla. And you will find that although Tesla is very good, but the average is something like that. Between 80 to 160 kilometers, you can easily do in any of the cars that you have today. Now, we have done that, we do about 72,000 trips in a year. But most of the trips that we do, I know that we go for the next door grocery store, which is hardly half a kilometer, and we go by car. So those days are gone, but we hardly move, and we take cars even going half a kilometer. So half of our trip that we have, the 70,000, is less than 5 kilometers. And more than 90% of the trips are less than 30 kilometers. And 99% trips are less than 120 kilometers. So most of the trips are very, very small, even 120 kilometers, which is in the range of electric vehicle, any electric vehicle that I've talked to you, right? At least it can resolve that issue. My biggest problem is the charging infrastructure. And let us look at the standard charge. And if you look at it, the standard charge, it takes you between 6 to 8 hours. Okay, the fast charge is between 2 to 3 hours, and the rapid charge is between 10 to 20 minutes. Whereas in your IC engine, you do the same thing in 2 minutes, 3 minutes, and that is a problem. Okay, naturally, this is all right if we were to charge at home, commercial premises or public facilities. But here, we may find that be a lot easier if we just do a changeover of the batteries. So, how can the home charging be done? According to some of the standards, you will not be allowed to do home charging, and I'll talk to you in my second lecture that it will be banned very soon. But this can be installed by any electrician. And it all depends on the site, and if the site is convenient, they can be done very quickly. You can either do a bollard model or wall mounted or domestic type, and these are the different type of charge point that you have. Now, the cost at the infrastructure. So naturally, any infrastructure that you make, you remember I told you about level 1 and 2, it will charge you up to, if it's indoor, you can be charged about $4,000 if it is a single unit. Be slightly less if you are doing multiple units. Similarly, if you're doing it outdoor, the cost is much higher. Okay. Naturally, if you're looking, most of us put our car in a domestic garage. Okay. But although I've given you installation cost, but this will depend on the site. And naturally, in commercial car park, the cost will be higher. Again, it will depend on the complexity. And lastly, if you need an on-street bollard, okay, this could increase depending on how many you want to install. So one of the things which is most important with the electric vehicle is that compared to your IC engine, this blue one, which is the IC engine, okay, your electric vehicle, your greenhouse gas emission is much lower. That is why we can say that this is a green power, my friend. Okay, so this is a real renewable uh, product, and therefore people have got their preference. Naturally, if you look from uh, the various vehicles that you have, whether it is I was talking to you about Nissan Leaf, right? The greenhouse gas emission is a bit higher than others. Okay, this is what in China you see that many people are using this e-cycle. Um, and although this doesn't ease traffic congestion and there are issues with parking, but at least everything is there in that cycle. It's an easy way um, of going from one end to the other. Naturally, it's not as good as walking or cycling normally or using public transport, but very commonly you see that this is happening, and this will also create traffic congestion and gives you parking issues where you're going to park your bicycle, and also embedded energy in the battery in the car components. So nowadays we are looking very closely at our transport system, and you will find that transport system will have a place where you can take your e-bike with you, and you have to be careful that you can put your e-bike in the train or any public transport. So you have to redesign your transport system. Naturally, you need to have rapid charging stations, so that could be one of the way. You can use the catenary principle on many routes. Okay, this will have impacts differently, but there are improved opportunities for controlled charging. What is the uptake like? And these are some of the modelings that we have done. We see that majority of the people by 2030, there will be quite a bit of concentration on batteries. See, the plug-in hybrid is there. Hybrids are already there because we drive large cars in Melbourne. I mean, I have preference of driving a six-cylinder, 4,000 cc car, right? And that type of car consumes a lot of petrol. It gives me only 4 kilometers per liter, so it's not at all a good way. So I took the initiative from the government, and the government gave initiative saying that you can have a hybrid vehicle with natural gas in it. So we don't use LNG over here; we use LPG. So I had LPG cylinder put in my car. Now those are becoming obsolete because now we're going to get plug-in hybrid vehicles more and more. Then comes what are the factors which will impact your electric side? One is the how many people will go for hybrid. Right? Naturally, it will have limited impact. The size of the vehicle, um, and naturally, people prefer to have smaller size vehicle. Not everyone is like me who likes big cars, right? The spatial clusters will favor or influence the early adopter communities, and the charge management initiatives will dictate all the network impact, which will have a tremendous impact on our electricity sector. So if you look carefully, uh, this is our maximum load on various state of Australia. This is Australian Capital Territory. The green one that you see is New South Wales, and this is my state, Victoria, the orange one, or the gold one. So the maximum load differs. Look at that. The maximum load in New South Wales is different than the maximum load in Victoria, and is different than that in Queensland. And naturally, it is different time because we've got various time zones in Australia. There are 5 time zones in Australia. Therefore, the loads are different at different times. Now, then we could have had additional loads, peak demand, and this is according to our NEM, that is National Electricity Market. And you will see that if it is unmanaged and if the peak demand is high, it could be like that, right, in 2030, right? But hopefully that will be central, and therefore this will be the peak demand. This thing that you see, it'll be on time of usage, okay? And this will tell you if there's a smart system that you have in place. And I'll talk a bit on that in the next presentation. These are some of the additional peak demand that we have, right? for the unmanaged system and the forecast that we have done, the forecast study which has been taking place. Now, therefore, some additional cost will be about $10,000 per every electrical, and this will have impact on distribution more than in generation and transmission. Now, who will be the early adopters? And They will be the one who will be of average income. They have high level of have to do the transition, and that transition has to be done in the next 5 years. You find that there are different scenarios. One scenario is with the internal combustion engine, and the other scenario is with the electric vehicle. You can see that the cost is dramatically increasing to about $1,300 billion compared to $1,100 billion. So if you have 100% electric vehicle, this will have additional demand. If you look at it, this is the additional demand will come in, and this has to be managed. Now, the power of choice, and that is according to our Australian Electricity Market Corporation. Um, and they say that this is a potential form of demand response. Sorry. And this is the technology is neutral, and this will give you the choice. The customer has the choice. I don't like to use the word customer these days because they're no longer customers. I call them prosumers. That means they are producers as well as consumers. So no one is a customer these days. Now, some of the key projects which are there, um, and these are these in our market commission, and this has been decided by our Ministry Council for Engineers, right? For energy, uh, just like you have your Council of Energy over there in India, we too also have MCE, and you look at that situation, that this is where the electric vehicles will be reviewed over and over again. So the wholesale market is not impacted, but definitely the retail market will be substantially impacted. So now the distribution service providers can directly participate in wholesale market. Consumers will be able to have different parties from different services. They don't have to be dependent on someone which is there for a long period of time, uh, and then they will become part of the network planning. However, the tariffs will be a very big question, and we will have to make sure that we can actually have some form of uh, some form of tariff for the distribution network so that everyone doesn't put their electric car charging at the same time. Now, this will encourage commercial investment. It'll give you better access, and it'll give you greater coordination between measures for electrical engineers as well as the distribution service providers. Now, time varying network tariff, and this is what I think will become. You won't have off peak and on peak because this must reflect more in your consumers' bills, and it must be cost related. And you must encourage your customers to respond appropriately. Retailers will remain free to decide how they will incorporate the offers that they get. So if you look at the electricity prices, um, 80% of the cost will be time varying, whether it is distribution, wholesale price, or retail price. Renewable has a small portion, right? Um, but these are most of them are time varying, either off peak or on peak. And look at the time varying network tariffs that we have. We will have different tariffs where you can opt in or opt out. This will be the mandatory one where all the residential and small business consumers will be, and their tariff will be the most. Can you see that tariff will be the most? Whereas the medium size to large size residential and small consumers will have a bit less, and the cheapest one will be the medium residential and small business consumers. Now, vehicle to grid. Now, V2G is a very important portion, okay, when you supply the energy back to the grid. And where you can do is you can use large number of grid connected batteries. And this is used for distributed storage. And you need to integrate the renewables. Okay, again, the success of vehicle to grid will depend on the life of the battery. Okay, now the manufacturers have to give you better warranty. Then the concern, what happens? How can you return the discharge back to the vehicle? Then the traffic arrangement. Now, if you have higher tariff for V2G, then the consumers will pay, and the critical mass of EV, which will give you aggregation of services. So the possible areas of value from storage will be arbitrage, right? Off peak or peak difference is usually not very large. And the FCAS, which is frequency control ancillary service. But FCAS is cheap in the national electricity market. The augmentation of the network, okay, this will justify the cost, and also any other integration issues that you might have. So when you look at large scale battery versus electric vehicle, in large scale battery, you have got this upfront cost, whereas here, the upfront cost is minimum. Here, the installation that you have is justified by the network deferment. Okay, here you have got a high inconvenience cost. Okay, minimal operating cost, whereas this is business case likely to be rare for extreme circumstances. And if you install it once, you install it for all time, and you will have the price arbitrage and frequency control, okay, issues. Now, the ancillary services by the frequency control, there has to be some regulation, okay, and the contingency will be based on time, and EV may be well suited for any contingency services because it'll be really called upon. Contingency services are more expensive to provide at present. So, what are the options for vehicle to grid? That is, the vehicle supplies the grid. You've got technical challenges over there. You have to make sure your tariff is adjusted. Then you've got V2H, which is vehicle to home. And I'll be talking about this again in my second presentation. Yeah, there is no export, but this is very technically very simple. Now, this will only be attractive when the home is on strong time of use tariffs. So you need to manage your charging depending on the vast majority of benefits without much hassles. Now, how can you contribute uh, by doing mass production of battery? Just like I told you, the Chinese have done that. Then you do your technology improvement by doing more and more simulation work, and you reuse the battery. So, in conclusion, I can say that electric vehicle is inevitable. Whether we like it or not, we will have electric vehicle, right? There will be incentive for charge management. Uh, you have power of choice review. You've got a very significant impact on peak demand. Vehicle to grid V2G may have a limited application, it'll be ideal, but will be called upon rarely. Then I want to show you the last bit that I wanted to show you in another 10 minutes. Uh, Now, this is the one I took. This is in Australia. We are already doing this. This is from the website of our um, one of our distribution company, which is Australian Gas and Light, and they've already created 1 million smart customers across homes, and this has become a preeminent customer choice for competitive and connected energy products. Look at that. They already have incorporated electric vehicle service. Besides the other thing, in large commercial one, you find they've already done the electric. They've got all these small commercial and commercial ed services, but I wanted to stress they've already done the electric vehicle services in their sector. This is again something which is here in Australia at the moment. You've got an electric vehicle, you've got a charging cable, and there is the distribution board. This is the charging outlet, and this goes directly to the distribution network. So you need some energy from the external source, and that is where it's getting it. Now, the way it will be that we started this cycle going when the technology started in 2008. Okay, 2011 there was a lot of expectation. Then it went through a lot of trough when many people were disillusioned by this electric car, especially when we heard about 5 years back that in the Autobahn, someone was killed in one of the best electric vehicles that you can think of because that person was driving and watching a television. Although it was an autoless car, it did not, there was a dead end in the rear mirror and it could not see it, and the sensors did not pick it up, and there was a massive crash. Autobahn, you drive at unspeeded limit, and there's no limit over there in Autobahn in Germany, and that car was driving, and that created quite a bit of disillusion, and people thought that we'd not go for that, but that has been overcome, and we are now back into enlightenment. Now, I think we are going to have quite a bit of uptake in electricity market using EV by 2030. Uh, we already know that by 2030 we will reduce substantial amount of CO2 emissions. Now, some outlook for Australia. I think this is what Mitsubishi will be the most selling cars. Okay, followed by Tesla, and then the rest of them. Um, then most of the government fleets now slowly and steadily have started to put in. There are about 7,500 fleets which is there, which is using electric cars. So there are incentive now to buy electric cars. Then comes connectivity. It'll be completely integrated vehicle, right? The transport will be there, the system will be there, the charging, and it'll show all the various type of work that is involved in it. So you will find integration will occur over multiple domains between all these sectors. Again, as I told you, this is the type of car that is roaming around in the street of Melbourne. Okay, this car, and this is the charging point. This person is charging his car. Okay, in India, what is happening, and I'll just quickly go through it. There is a big increase because of the low emission that is required, uh, and it is very important that you realize that because you have to understand that we have to look at the context of the grid, and has to be energy management over there. So, so in the United States, they have done the same type of thing when they started deploying electric vehicle. Uh, but you have to make sure that you've got enough charging vehicle charging places that you can charge, or else if there are not enough charging station, you will have in problems. Look at the number of cars that has gone in California, how much charging infrastructure has increased. Now, we've got other opportunities with smart integration. You can have V2X rather than just going V2G or V2H. Okay, you can take anything, and you will find that the whole smart charging infrastructure, you will have a huge amount of battery electric vehicle. You will find that they will be integrated and interoperable power system, distributed generation, two-way power flow, and you will have real-time communication. Um, this is the duck I was talking to you about. You look at the pattern. Um, this is exactly how the vehicle to grid integration will produce you a lot of opportunities. So there'll be a lot of communications and control of energy resources. Okay. Sorry. There will be generation and DER integration. Then there will be lack of EV and EV um, SE type of interoperability will be there. Again, look at various type of networks and electricity service providers, which will provide you vehicle to grid integration. So you look at some of this, uh, which is there, is already there because of the various plans which are there, which has got software and systems for the largest workplace charging. This is the charging, uh, and it's been done very clearly. And this is done in California. Now, you also have another type of storage firm. These are the various charging stations, and they're using cloud for the infrastructure. Then the open vehicle grid information will be there, right? So this will give you a lot of footprint. So in India, I think the huge thing will be that the road motor vehicle adoption rate per capita is still the lowest in the world. And with India's history in leapfrogging innovation cycle, that is, we have seen examples from telecom and internet. Electric mobility policies can support sustainable growth and new economy. You will find urban cities with deteriorating air quality can be the front line. And I will show it to you in New Delhi, where it is a horrible situation, and they have curved it with having electric rickshaws. And I'll show you the two and three and four wheelers that are there in India right at the end of my lecture, in the second lecture, where they have curbed the pollution issue and brought the pollution under control. So you find the smart charging battery electric vehicle technologies, which is vehicle to the grid and power system integration, will provide market-based dispatchable grid resources for variable generation. Now you will have interoperability and cybersecurity, which will lower the barriers for vehicle to grid or V1G or V2G and accelerate electric mobility. You will find Indian national mission must consider technical and regulatory challenge. That will be the greatest challenge that India will have, when they will have to do a lot of challenges between technical issues and regulatory issues. And that can help you leapfrog in the EV ownership. Now, the lesson that you have learned from vehicle to grid can serve as a model for India to accelerate adoption of EVs, decarbonize the electric grid, and improve the air quality in urban cities. Now you'll have inter and intra-ministry coordination between Ministry of Human Resources, Ministry of Power, MNRE, Ministry of Natural Resources and Energy. It is necessary that this will all execute the integrated clean energy and give you clean transport goals. With that, Niti, I have completed my presentation.
Thank you so much, sir, for giving us more insights about electric vehicles. Right
Yep.
from basics, you have challenges and opportunities. We have seen many charging stations, which have you have shown us from various countries, and charging infrastructure and the regulations you have covered very well, sir. I hope the participants will take lots of so many questions here, sir. So let's start with the first question. Somebody is asking in Tesla's variant, there is IoT.
IoT is a different thing completely. Now, do you have another 2 hours to give me to talk about IoT? Because IoT, the Internet of Things, is completely going to change the whole scenario. We are doing a lot of studies in IoT at the moment, looking at vehicle to grid, vehicle to houses, looking at vehicle to vehicle. No, that is a different game plan. The new comp structure will come. IoT will completely change everything. Now, that is a different topic completely, and that is beyond the scope of today's lecture. I've lost your voice, Niti. Your voice is gone. Now it's all right.
Sir, if you can, yeah, if you can please stop sharing, sir, we will be having the speakers.
Sorry?
We'll be having the, yes. Okay, thank you so much, sir. Thank you so much.
You're
The next
welcome. Okay, then. All the best. So I will see you after
next
1 hour.
questions also. But if you want, we can take up that in the next session, or if you want
Yeah,
to
next
continue.
session. We will do it next session. Because there must be
Sure,
someone
sure,
else
sir.
waiting for
So
the next
all the
session. I've
participants.
already gone over time. Um, uh,
Okay, okay,
Dr. Jain
okay,
told me
okay.
to finish it
Thank you
at
so much.
6:30.
Thank you so much, sir. We'll be
Okay.
logging again at 3 to 4 so,
Yep.
as per the Indian Standard Time. Thank you so much. The
Okay.
participants, second session of today's as per the timing 3 to 4 p.m. So thank you so much, sir. Thank you all the participants for joining. We'll be covering the questions and names.
Bye-bye.
Okay, bye, sir. Thank you.